Welcome to another video of time value of money. In this video, we will understand the concept of present value of a perpetuity. So what is a perpetuity? Perpetuity is an annuity with infinite time period. So perpetuity is a fixed amount of money paid or received for an infinite time period. In other words, perpetuity can be defined as a series of payments that have a specified date of start but no maturity as they continue forever. So either the perpetuity can have the same equal payments every period, or they can have growing payments, as we have seen earlier in the video for growing annuities. Now, in order to understand how to find the present value of a perpetuity, let us first understand how the calculations work in case of an ordinary annuity. So let's take an example of an ordinary annuity. So let me draw the time scale. So 0, 1, 2, 3. Now let's say the present value of this annuity is 272.32 rupees and the annuity amounts is 100 rupees at the end of each year. So let's say this is negative, that means it is going out from our pocket. So we are investing this amount and we are getting 100 rupees at the end of each year into our pocket. The rate of interest is 5%. So basically what is happening is that once you deposit this amount in the bank at 5%, this amount will gain 5% during this time frame. Now what is 5% added to this amount? So 272.32 into 1.05, this is equal to 285.936. So basically this amount has converted into 285.936 rupees at the end of the first year. Now from this amount, 100 rupees are given away into your pocket. So basically the bank has given away 100 rupees here. So now the remaining balance is 185.936. So basically at the end of first year, the bank has 185.936 rupees. Now this again will get a 5% interest. So this multiplied by 1.05 is equal to 195.2328. So at the end of second year, the bank now has 195.2328 rupees. From this again, they are going to give 100 rupees to you back. So minus 100. So now the bank has 95.2328 rupees. So at the end of second year, the bank now has 95.2328 rupees. This again will get 5% interest. So this into 1.05. So this is equal to 99.99, or I can say it is equal to 100 rupees. Now this 100, again the bank will pay out 100 rupees. So minus 100, and then the balance is 0. So here the bank now has 0 balance, as the bank has paid out all the money back to you in the form of this annuity. So as you can see here, the original amount is continuously reducing at the end of every year. and finally becomes zero at the end of the tenure. And why is that happening? Because the gain of interest on this amount is less than the amount that we are withdrawing at the end of each year. For example, for the first year, the amount grew by 285 minus 273, which is approximately 13 rupees. And we withdrew 100 rupees. Then again next year, the balance grew by 195 minus 185, which is 10 rupees, whereas we withdrew 100 rupees. So that's why the amount of money with the bank is slowly diminishing and it becomes zero at the end of the tenure. Now, if we have to continue paying out an amount on a regular basis for infinity, that means infinitely long tenure, then basically the interest gained or the amount of money gained in that 1 year should be equal to the payout at the end of that year. So if this is present value, if this is I and this is the annuity amount, then PV into I should be equal to A. In other words, if I draw a time scale 0, 1, 2, 3, 272.32, and if this is 5%, so basically 5% of 272.32, let's say, is 13.616. So at the end of the first year, the bank has 272.32 plus 13.616 rupees for us, which is nothing but 285.936. So at the end of first year, the payout should not be more than 13.616. So at the end of first year, again, the bank has 272.32. Then again for second year, the bank will accumulate 5% interest on top of this amount, and then will pay out the interest that is gained during the second year. So payout will again be the same, and again the bank will have 272.32 rupees. So then the bank can continue giving this payout for an infinitely long period because the original amount is not diminishing. So this becomes a case of perpetuity. And in case of perpetuity, the present value or the value of the perpetuity multiplied by the interest rate is equal to the annuity amount, or present value of the perpetuity is equal to annuity amount divided by interest rate. So let us look at an example to understand this better. An investor expects to receive INR 600. INR is the currency of India, which is Indian rupee. So an investor expects to receive INR 600 annually from his investment. What is the present value of the perpetuity if the rate of interest is 10%? So this is a case of perpetuity. Let's draw the time scale. So 0, 1, 2, 3, and so on. The amount of annuity expected is 600 rupees each year, and the rate of interest is 10%, and we want to find out what is the present value or how much should be invested today. So as we know, in case of perpetuity, basically the amount of interest gained each year should be equal to the amount of payout. So the present value of the perpetuity into the interest rate should be equal to the annuity amount. So PV is equal to A divided by I, which is equal to 600 divided by 0.1, which is equal to 6,000 rupees. So 6,000 is the present value of this perpetuity. So let us now look at the mathematical derivation of the formula for the present value of a perpetuity. So let's say this is our perpetuity, where I is the rate of interest per annum and A is the amount of perpetuity or amount of annuity. I mean, perpetuity is nothing but an annuity with an infinite time period. So we can call this amount as annuity or perpetuity. Now, in order to find the present value, basically each of these annuities or perpetuities has to be discounted. So let's say this is PV1. So PV1, when put into a bank or any other form where we can get I% interest rate, then we'll be able to convert this PV1 into A at the end of first year. Similarly, PV2 after 2 years at I% per annum will get converted into A, and so on. And this PV, that is the overall present value of this overall perpetuity, is equal to PV1 plus PV2 plus PV3 and so on. So PV will be equal to PV1 plus PV2 plus PV3 and so on. Now we know that the formula for future value is present value into 1 plus I to the power n. This is basically nothing but the formula for compound interest also. So compound interest, we say A is equal to P into 1 plus I to the power n. N is the number of compounding periods and I is the rate of interest per compounding period. So PV is equal to FV divided by 1 plus I to the power n. So our PV1 is FV1 divided by 1 plus I to the power n1. PV2 is FV2 divided by 1 plus I to the power n2. PV3 is FV3 divided by 1 plus I to the power n3 and so on. Now FV1 is A, 1 plus I, and n1 is 1. So n1 is the duration for which A is being discounted, plus FV2 again is A divided by 1 plus I, and n2 here is 2, plus FV3 again is A divided by 1 plus I to the power 3 and so on. So this is the generic form to find out the present value of a perpetuity. Now, as we know, a geometric series is represented as A plus AR plus AR square plus AR cube and so on. So in a geometric series, what happens is that if you take two consecutive numbers, then they have the same ratio. For example, AR divided by A, so AR divided by A is equal to R. Similarly, let's take these two. So AR square divided by AR is also R. Let's take these two. So AR cube divided by AR square is also equal to R. So based on this geometric series concept, Let us see if our present value of perpetuity is also a geometric series. So let's find out the ratio of two consecutive numbers here. So a divided by 1 plus I square divided by a divided by 1 plus I. A gets cancelled, this gets cancelled with this, so this becomes 1 divided by 1 plus I. Let's take these two. So a into 1 plus I cube, this is a divided by 1 plus I cube, whole divided by a divided by 1 plus I square. So a gets cancelled, this gets cancelled with this, so this is 1 divided by 1 plus I. So here again the ratio of two consecutive numbers is the same. So this present value represents a geometric series. Now in case of a geometric series like a plus ar square plus ar cube and so on, basically a is the starting number of the series and r represents the ratio. So in that case, if the series is infinitely large, then the sum of this series is a divided by 1 minus r. So for the present value of perpetuity, let's identify what is a and what is r. So a is the beginning number, which is a divided by 1 plus I, and r is the ratio, which is 1 divided by 1 plus I. So now let's find out the sum. So present value is equal to a, which is a divided by 1 plus I, whole divided by 1 minus r, which is 1 divided by 1 plus I. So this is equal to a divided by 1 plus I. Now let's take the LCM as 1 plus I minus 1 divided by 1 plus I. Now this 1 plus I gets cancelled, and this 1 minus 1 gets cancelled, so this becomes a divided by I. So basically PV is equal to a divided by I. So this is the mathematical derivation of the present value of a perpetuity.